This video is a continuation of the previous one where we go through the wiring of the devices in the sprinkler room of our 5-story building. We finished the last video with the test header valve, so we'll pick up with the dry system. If you don't know what a dry system is or how it works, go back and watch video 18. I'd also encourage you to go to Viking's website and look at some of their videos. They have a great compilation of videos and animations which explain the various valves they offer. As a brief explanation of what a dry system is, it's a sprinkler system that has compressed air in its pipes rather than water. It's installed in areas where temperatures get low enough to potentially freeze any water that would otherwise be in the pipes. On the other side of the valve is the sprinkler water. The pressure of the compressed air in the pipe holds shut the clapper inside the valve. When a sprinkler head bursts, the air in the system drains out, which relieves the pressure on the spring-loaded clapper. The pressure from the water below the valve is then strong enough to push open the valve, filling the pipe with water and hopefully extinguishing the fire. Below the dry valve is always a shutoff valve, usually a butterfly style valve. Since we've already seen how to wire these in the previous video, we'll wire this one up to the next point on our XP10. We'll bring one wire from the module to common, the other to normally open, and we'll put the resistor across the other pair of common and normally open wires from the tamper switch, and tape off the normally closed wires. There are two other devices we need to monitor on the dry system. Because the dry system requires compressed air to keep the valve from tripping, we need to monitor the air pressure in the line. If we begin to lose pressure, it indicates that there's a leak in the system or that the compressor has failed, and the system is going to trip if we don't fix the problem. This is done with a low air pressure switch. We're using a Potter PS40-2. This device will be piped into the system so that whatever air pressure is in the sprinkler line is measured by the switch. Just to the right of the switch is the air pressure gauge, which lets us know how much pressure is in the pipe. Shown here with its cover off, you can see there are two switches on the PS40. These ship with stickers on them, one side marked high and the other side marked low. There's also a little rotary dial that allows you to adjust the pressure at which the switch will activate. It should be about 10 psi below the ambient pressure in the pipe. We need to wire our module into the low switch because we want to know when the system is losing pressure. There's really no harm in also jumping over to the high switch to monitor that as well, but I've only seen people do that a handful of times. It's possible that the system could get filled with too much air pressure if the regulator on the compressor failed. That would cause a problem because if the system had too much pressure, it would take longer for the system to drain in the event of a fire. For the purposes of this video, we're just going to monitor the low air side of the switch. The terminals on the switch are labeled common, 1, and 2. If you look at the installation document, 2 should be the normally open contact when the system is pressurized and the switch is calibrated. We should throw a meter on here to confirm. We're going to take a pair of orange wires, wire them into the next point on the module. The first wire will land on common, the next will land on terminal 2, and the resistor will go across the pair. The last dry system condition we have to monitor will be the water flow switch. On a dry system, there's another pressure switch that looks similar to the low air switch, but it's piped into the dry valve such that when the valve trips and the sprinkler pipe gets filled with water, the water also hits the bottom of this pressure switch, causing it to activate. This should generate a fire alarm condition on the panel. Looking at this switch with the cover off, there are two sets of contacts on it, similar to the low air switch. However, in this case, both of them do the same thing and will activate at the same time. One of them gets wired into the fire alarm panel and the other to the water flow bell, which we'll see shortly. The terminals are labeled common, 1, and 2. Looking at the installation sheet, you can see terminal 1 should be normally open. We can verify with our meter, then wire it into the next point on the XP10. The next 2 points we have to monitor are the valve tamper and water flow switch on the main sprinkler riser. This pipe feeds the riser that goes up the building in the stairwell. We've seen enough of these butterfly valves, so we'll get through this quickly. We'll wire the next available point on the XP10 to the common and normally open wires on the valve tamper and place the resistor across the other pair, then tape off the normally closed wires. Now on to the water flow switch. A water flow switch is a device that's mounted on the sprinkler pipe and has a paddle that goes down into the pipe. When water flows in the pipe, it pushes the paddle, which activates the switch. There's a delay mechanism on the water flow switch, which prevents small pressure fluctuations from causing nuisance alarms. I encourage you to go to Potter's website to watch some of the videos they have on this topic. We will connect this switch to our module in a similar way to the pressure switch on the dry system. We're going to bring a wire from the module to the common terminal, then the other wire to the normally open terminal. Then the resistor will go across the two. Now on to the water flow bell. Water flow bells are not technically fire alarm devices. They're supplied by sprinkler fitters and installed by electricians, but we still have to know how they work and often have to troubleshoot and replace them once they're installed. Plus, electricians watch these videos. If a sprinkler head bursts and water starts flowing, the bell should ring. It should not be silenceable until the water stops flowing, at which point it stops ringing automatically. There's typically a bell in the sprinkler room and another bell outside by the fire department connection. They're wired in parallel, so if one goes off, they both do. Notice here how the conduit that's feeding the bell is separate from the conduit feeding our fire alarm equipment, including separate whips to the devices. This is important because in most cases the bells are non-power limited 120 volt circuits that must be kept separated from our low voltage circuits. Bells are simple 120 volt devices similar to a light bulb. If they get 120 volts, they ring. When they lose the voltage, they stop ringing. So you could imagine if we took a 120 volt circuit, a hot and a neutral wire, and connected it directly to the bell, it would always ring. If we installed a light switch and connected the hot feed to the switch and the switch leg to the bell, we could turn the bell on and off with the light switch. Think of the water flow switch as our light switch. We'll bring the hot wire into the water flow switch and land on common. Then, the switch leg from normally open to the bell. Now, whenever the water flow activates, the bell rings. The connection to the fire alarm panel will go on the other set of contacts here. So one set of contacts is for the fire alarm and the other is for the sprinkler bell. Our situation is slightly more complicated because we have two water flow devices that both need to be wired into the bell. It's still very simple though. We now make a splice in the junction box and basically wire each device up as if it were the only device in the circuit. We tap into the hot leg of the circuit, bring that to common of the pressure switch, then bring a wire from normally open of the pressure switch to the junction box and make the splice to the switch leg that goes up to the bell. We then do the same thing with the water flow switch. We add another wire from the hot feed to the common of the water flow switch. Then another wire from normally open of the water flow switch back to the switch leg splice, which goes up to the bell. Now, if we add in the connections to the module, you can see the 120 volt connections to the bell are on one side and the connections to the fire alarm module are on the other. Oftentimes, instead of wiring the bell through multiple devices like we did in this room, another water flow switch would be installed before the sprinkler line splits into multiple branches. If there was a water flow switch installed here, we could just wire that into the bell, and since water would have to flow through that device if either branch had water flowing, we'd be covered. Hopefully you get the idea. It works either way. The last few things we're going to monitor in this sprinkler room are the fire pump conditions. There are 3 conditions we need to monitor on the fire pump. We need to know when the fire pump is running. This can generate either an alarm or supervisory signal. We need to know when the fire pump has lost power. This will generate a supervisory signal. We need to know if the phases have been reversed, going to the motor. I should note that this is the case when you have an electric fire pump. If you had a diesel fire pump, some of the conditions would be different. If the electric pump phases were reversed, the pump would run in the wrong direction, which is obviously a problem. We'll program this condition as a supervisory as well. There are relay contacts on the fire pump that are meant for the fire alarm connections. Usually, you'll see a terminal block with factory wiring on one side connected to onboard relays. So for us, the connection is as simple as finding the wiring guide on the door and connecting our modules to the proper terminals. Be very careful when you're inside these cabinets. Even when you shut off the pump power to open the door, it's still live where the power comes in off the meter. If you're not comfortable working in there, it's possible the fire pump technician will make the connections for you. However, I'm not sure I would trust that everything was connected correctly and the resistors were tight enough to not cause a problem in the future. Just be aware that when you're in there, there's 480 volts live at the incoming connection, so be careful with your wires and screwdrivers. We used the last of the 10 available points on our XP10 when we were connecting our waterflow switch. So instead of using another 10-point card, we'll use a dual module and a single point monitor module for our remaining 3 points. The dual module works similar to the XP10, except it only has 2 points available. The notifier part number is FDM-1. You wire SLC in and out like you would to any module on terminals T1 and T2. When you set the address, the device takes up that address and the next highest address. So if we set this to module address 11, the lower terminals 6 and 7 on the bottom left of the module marked L for the lower address are point 11, and the upper terminals 8 and 9 marked H for the higher address are address 12. So first we bring the SLC in from the XP10 into the FDM, then down to the module below. Then we will take another SLC cable out from the bottom module, up and out to the next device in line. We'll make address 11 the point that monitors fire pump running. We'll take an orange wire from terminal 6 to the point on the pump controller's terminal block labeled common for fire pump run. Then the other wire from terminal 7 on the module to normally open with our resistor across the pair. Then we'll do the same for the fire pump power fail condition, this time coming out of the top 2 terminals 8 and 9. One wire from 8 to common on the controller, then another from 9 to normally open on the controller. Next, we'll wire up the single point module, called an FMM-1. This device looks the same as the one above it, but the terminals are labeled differently. The FMM-1 can support a single Class B circuit, or it can accommodate a Class A circuit. So you'd only use terminals 8 and 9 if you're wiring your module Class A, which we're not doing here. So we'll come off of terminals 6 and 7 and land on common and normally open terminals of the phase reversal terminal block inside the pump controller. Now, if any of these conditions occur, the associated relay contacts will change state, causing a short on our module and activating whatever condition we've programmed those points for in the fire alarm panel. Our sprinkler room is now completely wired up, and we can move on to the next section of the building.